for ASME.
Hello, and welcome to another episode of Advanced Manufacturing Live. Please remember to like and subscribe to our feed. I'm SME Media's Editor-in-Chief, Steve Plum.
And I'm Senior Editor, Michael McConnell.
And we're very pleased to be joined today by SK Gupta, co-founder and chief scientist of GrayMatter Robotics, where he leads the company's research into physical AI, computational decision-making, and human-centered robotics. He has authored more than 500 technical articles, spoken at 200 plus events, and previously served as a program director for the National Robotics Initiative. Prior to joining GrayMatter, which was formed in 2020, SK spent 10 years at the University of Southern California in various roles, including director of the Center for Advanced Manufacturing. He started his career as a research scientist at Carnegie Mellon's Robotics Institute before founding the director of Maryland Robotics Center. And I'm happy to say that among a long list of awards and honors, SK was elected as an SME fellow in 2020 and has been to numerous events. And before we jumped on the call, SK, you said you'd been an SME member since 1992 or 3?
93.
Yeah, well, welcome to the show, and it's great to meet you.
Great, absolutely. It's truly a pleasure. I'm very happy to be part of it. As I said, I became SME member in 1993. So when I was a graduate student, so I've had a long history with SME.
So we're glad to have you on the show today. But before we get too far into the conversation about AI, can you tell us a little bit more about GrayMatter and what was the impetus for founding the company?
Sure. So I have been working at the intersection of AI, robotics, and manufacturing throughout my career, right? So when I was at Carnegie Mellon University as a research scientist, then professor at University of Maryland, then professor at University of Southern California. So we have been doing work at this intersection. Roughly around 2017, 2018, we were at stage where we were building systems which had remarkable capabilities. We were doing the demos in my lab at USC called Center for Advanced Manufacturing. People were getting quite impressed by what we were able to do. And then a lot of companies will come by and then say, hey, SK, we need these technologies. We really need to get them now. So how do we get access to it? We explored different routes, and then in the end, it made sense for a company to start basically getting these technologies out and deployed. So we formed GrayMatter Robotics in January 2020. So GrayMatter Robotics, there are 3 co-founders, so I'm one of them, and 2 of my former PhD students, Aryan Kabir, who serves as the CEO of GrayMatter Robotics, and Brual Shah, also one of my former PhD student, who serves as the Chief Technology Officer for GrayMatter Robotics. So 3 of us co-founded GrayMatter Robotics in January 2020.
That's really taking mentoring to the next level, founding a company with 2 of your former students.
Yep.
SK, so want to ask you, starting this off, artificial intelligence has become a constant in growing presence in just about everybody's lives. It seems like in a relatively short period of time. Maybe not so short for you because you've been involved in it for a while. But there are a lot of different types: machine learning, generative AI, agentic AI, physical AI. What is physical AI, and how is that being used in manufacturing?
Sure. So you can broadly think about AI in 2 different categories. One is digital AI. So what digital AI does is it creates digital artifacts. So images, text, video, even audio. So these are digital artifacts, and then they can be consumed by a human, shared with some other computer. So that's kind of what digital AI does, right? So ChatGPT your favorite program for creating videos or your favorite program for creating images. These are all examples of digital AI. Then there's a physical AI. What physical AI produces is a action recommendation, which is followed by a physical agent, right? So action recommendation is given, for example, in case of self-driving car, you are basically saying, press the accelerator or apply a brake or turn left, turn right. So those are now physical action, which are being recommended by AI. Similar things in the field of robotics, where AI is producing the trajectory that robots should follow. So these things are now physical AI. So meaning that AI controls actions of a physical agent. So that's the key distinction. Now, all the approaches, the one which you talked about, whether we are doing machine learning, whether we are doing generative AI, whether we're doing deep learning, whether we're doing agentic, AI, these can be used in both frameworks. So there's no exclusivity. I mean, generative AI can be used in digital AI, generative AI can be used in physical AI. So in both, these are all tools and methods, and you can use them in either setting.
So what's interesting about GrayMatter, which you shared how the name came about, basically being the brains of a robot. But what I really like about the company and your background in manufacturing, sometimes software companies that are more focused on that side of it try to get into manufacturing, whereas you have an extensive background in manufacturing and are bringing AI into really the fundamentals of manufacturing, whether it's finishing, blasting, grinding. And to this end, earlier this year, GrayMatter introduced a factory superintelligence, which sounds really cool and super smart. But how does this differ from other competitive technologies and really being applied to high mix production, which is becoming more prevalent throughout the industry?
Sure. So our initial focus when we formed GrayMatter Robotics, 6.5 years ago, was focused on building robotic solutions for individual processes. So we were building solutions for sanding, then we expanded into polishing, grinding, blasting, inspection. So we were building individual solutions. And we were using AI to power each individual cells. That's kind of what our initial focus was. Now, when we started interacting with customers, it became clear to us that in order for us to unlock the value for the customers, where customer can really take great benefit from this technology, we cannot just be operating at individual cell level. We have to really think at the factory level, how different cells will talk to each other, how the entire process of deploying cells in a factory, maintaining cells and activating cells and self-improving system, all of this needs to be put in place. So we have to go well beyond just using AI to power individual cells. We have to look at the factory level. We have to look at the entire system level to make sure that we can deliver value to people, and therefore we can remove bottlenecks. We can, basically streamline the processes. So that was the thinking behind factory superintelligence. And I'll be happy to explain it to you, different layers of factory superintelligence and what constitutes factory superintelligence.
Well, SK, there was a lot of upsides related to Industry 4.0. Kind of you've touched on that a little bit, I think, what you were just talking about with automation and AI. But there's always this fear, a lot of people have that those technologies will end up supplanting, humans and human workers. What do you think the near and long-term impacts on the workforce might be?
So if you look at it, what goes on in a factory, right, from physical labor perspective, so a lot of physical work that humans end up doing, like sanding or grinding or painting or coating, a lot of this work is physically, very, very demanding. And if you do this over a sustained period of time, you're putting your own health at risk. So we believe the physical work, which can be injurious to people's health, should not be done by people. That's the work that we hope that we can get robots to do it. And then human can focus their attention on more value-added things. Obviously, there's a fair bit of work that requires teaching robot how to do a job well, inventing new process recipes, maintaining cells, ensuring quality. So there are lots of other things that human can offer tremendous value. And that's kind of the right split of work between humans and robot is, right? Let robot do really challenging, physically demanding tasks where they can actually even do work faster than human. And that's why we are not constrained by human physical constraints. I mean, robot can apply a lot more force than human could, right? So therefore, we can make manufacturing more efficient, more consistent, and remove all the health risks for humans. And human can take the aspect of robotics, which is more innovative, actually aspect of manufacturing, which is more innovative, more value add, and they can focus attention on that. So that's kind of right, ultimately, mix of work between robots and human. I genuinely believe that tomorrow's factory will be a team of robots, machines, humans, and AI, right? So you need to have the right role for each of these things. Without that, you cannot operate these factories efficiently.
So you don't think that people need to worry about factories? I mean, about AI and robots taking their jobs in these cases. These are not the jobs that people want to be doing long term.
Yeah. So right now, at GrayMatter, we are largely focused on robot doing the job that people absolutely do not want to do, and they should not be doing.
So the company's been around 6-7 years now. What were some of the low-hanging fruit applications that have been implemented now? Some of the tasks that you've focused on first?
So we began with sanding. So we have done a lot of work on sanding. Then we branched out into basically grinding, polishing, and blasting. So then we started support and buffing. And now we have a big initiatives in coating and inspection. So we keep adding these new technologies every time to our repertoire.
And have you been able to quantify benefits in these cases? I know I think I read somewhere reducing waste or inefficiency by 30 to 70% in some cases. Where are the savings coming from mainly?
So basically, let's take a look at it, sanding as an example, right? So sanding, what happens that when humans do sanding, the first waste comes in because when humans start using sandpaper as sandpaper wears, they basically very quickly throw it out because worn sandpaper requires you to apply much more force, and that's not good for you, right? So humans are not able to use sandpaper efficiently. So if you have robot doesn't care. Sandpaper wears, you monitor the state of sandpaper, and then you apply more pressure as the sandpaper wears. So robot can extract more useful life out of sandpaper than what human can. So that's your first gain right there, right? So you basically save significantly in terms of the sandpaper that you're consuming. So that's the first layer, right? Now, second layer comes at where if humans are sanding it, sometime, some mistakes get made, and then there's a rework. So, basically then somebody has to go rework. So you spend time reworking a piece, which basically, should have been done differently in the first round. Now, robot again are super consistent, right? So once the robot start working well, then the rework problem doesn't happen. I mean, if the robot has learned the recipe and is doing it, it's going to deliver you same consistent quality every single time. So second big saving come from basically on reducing rework. And the final saving that basically come from is eliminating waste. Sometimes when you're working on the part, your mistakes are so critical that you have damaged it, right? And you have to scrap it, right? So you get rid of those scraps as well. So consumable saving, rework savings, and scrap savings are the three components through which you basically gain those efficiencies.
And do you train the robots on like best performing humans, or do you take it beyond that?
We most of the time try to take beyond that.
Yeah.
Because again, a lot of times when you look at it, how humans do things, they are doing it principally based upon their own constraint, how much force they can apply, how fast they can move. Most of the manufacturing processes you could do significantly better than what humans can.
So another ongoing and huge issue in manufacturing and other industries is the workforce shortage and skills gap, which automation is stepping into the void to help out in that area. And one of the industries that has been affected is shipbuilding.
Mm-hmm.
The U.S. has been at a disadvantage for some time, and really trying to ramp up those operations and production in those areas. And to this end, you just recently signed a memorandum of understanding with Huntington Ingalls to explore physical AI and putting that into their manned and unmanned shipbuilding. It seems like the potential to be a really big deal. What can you share about the project?
Yeah, so this is basically a partnership that we are forming with HII, which allows us to basically take our technology in surface finishing treatment and other inspection processes and bring it to shipbuilding. So we are basically partnering with them to bring our technologies such as, grinding, coating, inspection, blasting to shipbuilding, both in the current shipyards where we are gonna, basically help them deal with the labor shortage problems, right? Where we can introduce these technologies and therefore add capacity. And we are also partnering with them to basically design the next generation shipyards, right? Where, we can reimagine how shipbuilding happens in the future. And therefore, from day one, we have thought about how to introduce automation in shipbuilding. Therefore, we can really design the kind of shipyard where it will be much easier to deploy robotic solutions. So that's kind of what partnership is. And we are going to continue to work with them, both for the existing shipyards as well as all the new shipyard, which they are thinking about.
Speaking of partnerships, you're working with Path Robotics on that project, is that right?
That's correct.
Okay. How important are partnerships like that for these types of projects?
Yeah, so these partnerships are super critical because each company brings in a different expertise, right? Path Robotics, for example, brings in expertise in welding. So, shipbuilding will need many different techniques, right? The kind of things that GrayMatter does, as well as other technologies such as welding, which is basically also critical to shipbuilding. So both of these things will, work together to make sure that we can offer shipbuilding industry complete solutions which they need to accelerate progress in that front.
So how far along is the project, and when might the public start to see some benefits from it?
So we are scheduled to, basically start doing things in a few months down the road. That's kind of where things are right now. That's all I can publicly tell you today. So, but this year, before end of this year.
Yeah. So you've been in AI as long as anyone. I think you said you wrote a thesis paper on it way back when.
Yeah, I mean, I started working on AI first when I was a master's student in 1989. And that time we were looking into expert systems. AI has also changed over time. So at that time we were looking into rule-based expert systems to do manufacturing process planning. So that's how I got into AI.
So as Mike had noted earlier, it's really sped up recently, the implementation, the acceptance. Was there a point in time, that really enabled that?
Definitely. So we started seeing, so AI demos were there, right? There were principally three challenges, right? Challenge number one was compute wasn't there. So that simply meant that you couldn't solve anything interesting. You can solve simple problems, right? But you couldn't do anything which was really complex, right? So compute limited you quite a bit, right? The second thing was that first few generation of AI, humans were, devising algorithms, collecting rules, doing things, right? First generation of AI were not data driven, right? So they were still, human will craft a clever rule and then inferencing engine will use it, right? So then we were constrained by how fast human could code or conceive or detect a pattern. So then came along data-driven approaches. So machine learning is largely data-driven approach, right? And as more and more data became available, that started propelling AI forward very, very quickly. So, for example, latest large language models are propelled by people scraping all internet data, right? And therefore could design systems which are super smart, right? So getting hands on data became super important, right? Computing, as you know, large advances in GPU propelled us and gave us enough compute capability. Then as the data got accumulated, people had enough data, and we got data. And finally, sensing, right? So in order for you to use AI in a, really physical AI in a really safe, trustworthy, and intelligent way, you need to have a lot of sensors, which are going to give you data. So now we can basically put cameras, force sensor, temperature sensors everywhere, right? So availability of data, availability of compute, and availability of sensing, which again came about with smartphone have now so many sensors integrated in it. So eventually, I would say around 2016, 17, we had enough of infrastructure in all these three areas where we could really solve meaningful, complex problem in a very short period of time, which then unlocks the value, meaning that then now makes sense for somebody to actually really start using it in some meaningful way.
So I imagine Moore's law plays into that advancement. The number of transistors doubling about every 2 years.
Absolutely.
Has AI surpassed that now? And where do you envision the industry going in the next 3 to 5 years?
So I mean, again, people will be able to expand, right? There are certain applications which we can automate with physical AI today, right? And obviously, scope of what we will be able to automate will expand quite a bit in the next 3 to 5 years. I mean, we'll be able to handle more complex problems. We'll be able to handle more level of ambiguity. We'll be able to, make things much more safer. So I think overall things which we will be able to do with AI will expand quite a bit in the next 3 to 5 years.
Putting your forecaster hat on, is it even possible to predict, 10, 20 years out on what potential capabilities might be out there?
I am unable to foresee anything beyond 3 years. Right now, things are changing so fast that 3 years is like my limit. I cannot predict anything beyond that because things are changing fast. Lot of moving pieces, lot of interactions among different components. It's kind of very difficult to even imagine how things are going to look beyond 3 years.
Well, I won't ask you then to forecast that far out either, but for now for now at least, and maybe for the future, how important is it, SK, to keep humans in the loop? To use that common phrase.
it's super critical to keep humans in the loop, right? Because ultimately, we are going to constantly demanding new things, right? New products. And new level of capabilities, new level of performance. Only humans know what humans want. AI never going to know what humans want, right? So we are going to be the custodian consumers of what AI produces, right? So if humans are not in the loop, I'm not quite sure if AI will, be able to generate anything meaningful, which will be valuable to people. And therefore, I believe humans need to be in the loop, on the loop, right? So humans are going to be an integral part of this entire journey going forward.
Well, speaking as a human, I'm very happy to hear that for all humans everywhere. I know we're almost out of time, but what's next for GrayMatter? I know you just moved into a new headquarters facility last year. You said you're already outgrowing that. And also, what are some of the challenges that still need to be overcome to accelerate implementation and improve capabilities and efficiencies?
We have a long roadmap ahead of us of the processes for where we would like to get AI-powered robot working. So currently, inspection and coating, painting, spraying is something that we are planning to roll out later this year. After that, we are looking into assembly. We are looking into all kind of machining, cutting type of application, a lot of composite fabrication. So there are lots of things ahead of us, which will happen over the next couple of years.
Well, thanks for joining us. It's been very informative, and look forward to talking to you more and hopefully seeing you later in the year at FabTech.
Yeah, absolutely. Very much looking forward to seeing you at FabTech.
Well, thank you again, SK. And thank everyone for listening live today. And remember that the recording is always available on demand at advancedmanufacturing.org and on multiple podcast platforms and other social media channels. And please remember to watch the next episode of AM Live on June 25th.
Thank you for inviting me.
Thank you.